Yeah, thanks for the introduction. Hi guys. I'll do my screen sharing and we'll get started. So screen share. All right. So is the screen sharing going through all right?
It is.
Yeah, nice. Okay, cool. Yeah. All right. So let's get started. I actually changed the title a bit. I've seen, or just to be a bit more, I guess, clear on what it's actually about. This is, I guess, we can also have a talk about that at the end. But crash resilient programming, probably a better term for it. But yeah, we'll get back to that, and I guess during the presentation we'll see why that makes sense. Yeah. So the agenda that I've I guess compiled is that initially we'll investigate the problem, what it's about. We'll introduce the framework called Sleipnir.net. We'll look at a lot of examples, and then if we have time, we can look at some of the challenges of building a framework like this, doable execution framework. Also, I think at least I quite like it. We're also not that many people, but yeah. So if you have any questions, I guess just ask them when you have them, and we can look or we can answer them immediately. And if there's some things you don't understand or anything, yeah, just reach out. I guess yeah, just ask on the microphone or yeah, write a comment. And we can have a look at that. I think it works quite nice, these presentations, when they're interactive. I might have a difficulty seeing you guys, but yeah, I guess just raise your hand or do, yeah, unmute the microphone and ask, and we'll have a look at it immediately. Yeah, so who am I? Let's get started with that. So I'm a software developer, as was said before. I'm actually just I'm employed in a new position at a consultancy company called Delegate. I have a master in computer science from Aarhus University in Denmark. I did the 2 years of unfinished PhD studies at Stavanger University, which is in Norway. And I've been working on some of the ideas that I got during the PhD. I changed a bit and created this open source framework called Sleipnir.net. Yeah, from that. I live in Denmark. I have a wife and 3 children. Yeah, in my spare time, I like to do cross fitness, hiking. I like to play FIFA with my son and spend time with my family. That's me, I guess. But enough about me. Let's get started with actually introducing the problem. I think the best way to understand what the framework tries to do and the kind of the space this is in is by looking at an example. And the go-to example in this field is really the order processing example, right? There's money involved, so it's important for companies that these things works always. So here we have a fairly simple example, right? We have to communicate with a payment provider in order to actually take the funds from the customer's credit card. We have to ask the products to be shipped. So we're sending out an external message to a logistic service. And finally, we're going to send an order confirmation email. So this is just like normal C# code, right? So we have some dependency injected clients that communicate. Let's just say it's over HTTP, and that's kind of like our starting point. And this code, as we see in the sunshine scenario, works fine, right? We're going to reserve the funds, ship the products, capture the funds, the credit card, and send an order confirmation email. So everything is good. Yeah.
Why don't you, right at the bottom of the screen, there's a little notification bug. Why don't you go ahead and hide that so it's not on the slides? There we go.
Idea,
Thanks.
Yeah. No worries. All right, yeah. So in the sunshine scenario, right, everything works out. It's fine. No worries. At this point in time, and I guess if you want to, you can join in. But what can go wrong? Do you have any like if you were implementing this, would you have any, or what would you be concerned about? Does anybody wanna go, or otherwise I can say what I normally hear.
I think you don't want to do all those steps if one, like in the beginning, fails. You don't want to send another confirmation if you weren't able to reserve it.
Sure. Yeah. That's true. Yeah. So if we're not able to reserve it right here, we don't want to do the other ones. This could be that we throw an exception, right? But that's true. So we could have like more involved try catch exception handling, right? That's true. And that's also normally, I guess, what I hear is this, or the kind of like immediate way that we look at these things is these external dependencies. How can they go wrong, right? Or how can they fail? And how we normally handle this is using either we hand code it or we use a framework like poly.net, if you know that, to try and handle these things. Of course, we can have we could have the payment provider client throw an exception, or we can have it actually return a value which indicates to us if we should continue or not. And depending on how far we got, of course, we might need to do some compensating steps, right? If we're unable to ship the product, we want to cancel the reservation and so on, right? So that's true. But another kind of error that can occur in a flow like this is if the process actually executing the code is the one that crashes. And for some reason, it's something that we don't normally give that much attention to. I guess it has various reasons, but it's interesting to also look at that perspective and see how it actually can go wrong. We can have a look here. I also wrote crash dash deployment, right? So it's actually so normally we talk about crashes, and people would normally have this kind of gut feeling that crashes are very rare, so we don't really need to, it won't affect us that much. But I've seen this of the way that we develop today in enterprise development, right, is that we also do frequent deployments. At least that's what a lot of people want to do, because it has some nice features, right? And when we do a deployment, we're actually inducing a crash, you could say, ourselves, right? Because we're restarting the pods or the replicas, the processes, and then starting up again. And if there's a lot of traffic going through, we will actually have the situation, which I'll show you now, can occur, right? So if we have a crash, right, we can have the case where we have a reservation that goes through, we can have the ship products going through, and then we crash, right? Then we'll end up with a situation where we've reserved the funds, we actually send the products to the customer, right? But nothing else will happen. So that's kind of like not a good situation for the company, right? And poly.net and I mean hand coding like this won't actually help us, right? There's some other things that we need to do. The next thing that we can then ask ourselves is if we can just restart. An important thing to say here is that I don't often in enterprise development we use these. There's two main approaches that people use, and one of them is like a job scheduler. So they would use a job in like Hangfire or Quartz.net to try and remedy the situation. Otherwise, they'll use a message buses, right, where a message will be redelivered, right. And in this case, we kind of like are sure that this half completed work will be picked up. But that leaves us then with another question: if it's okay just to restart the code, and the restart of the code will happen from the top, right? And I guess again, if you want to, can you say, or do you want to pitch in with your thoughts? Can we just restart this flow from the top if we have a failure or crash during the execution or on early execution?
Depends where it fails, but probably not. For example, if it failed to send the order confirmation email, I don't want to order it a second time.
Yeah, exactly. So there's something more going on here, right? It kind of like puts us into trouble and that's true. Yeah. So if we previously got to the point where we were about to send the order confirmation email and we did a restart or crash there, we'll actually start from the top again, right? And I think, yeah, actually we can jump into code and we can have a look at the situation. So this is the framework, but it's not important right now. We're just looking at the same code that we saw before, but inside, right? And we have this these steps here, and we'll just look at this restart problem. Yeah, right. So have a look. So if we go like this, right? So we'll do a transaction ID, right? It's A03, right? We go like before. We have these 4 steps, and we'll do a crash, and we'll do a restart. Yeah, and we got, so it's not A07 anymore, right? It's 8AF, and so the payment provider will have a new transaction ID. We'll ship the products again, and we capture the payments again. Right, so this can in principle go on again and again, right? So we can see that there's something, the code we actually wrote is kind of like not robust against these restarts. It will diverge, or it will do these unintended side effects, really. So let's get back to the presentation again. And so let's try and have a look at how we can actually remedy or fix the situation. And there's 3 abstractions, right? So we'll look at the code and also look at Sleipnir in specifically, but just from a mental model, I think it's quite good to just think about these 3 abstractions and how we can use them to actually handle this issue or fix this problem. So there's something called effects, which basically is a way that we can ensure that code is only executed once, and we'll remember the result of some code execution earlier, right? So we can use it again. Then we have messages, and these are for handling or waiting for external events before we're actually going to continue our code execution. And finally, we have this concept of suspension, right? That we want to release in-memory resources while waiting for some conditions. We don't want if there's something that's going to occur in a day or an hour or from some undetermined number of a period, then we don't want just to wait in memory for that, because then we'll exhaust all the resources on the process. Let's look at the effects first. So as said, they ensure the code is only executed once, and they remember the result conceptually. So it's kind of like there's no magic going on here. It's basically just, or the way that an effect works is basically just that it will, if it's a method like this, right, that we can call in our code, we'll give it some identifier, and we'll give it some function that we want it to execute, right? So we'll look at it again, but that could be kind of like the transaction ID we saw before. It will then check in the database or persistent storage if it already has a value, a previous value for this ID, and then it will get or use that value. If it doesn't already have one, it will invoke the function, it will save that value to the persistent storage, and then it will return the value, right? So that's how it works, and we'll see how that's nice. We can use it this is similar to the transaction ID, right? So we have a GUID, new GUID, request ID. So after this line of code has been executed, then if we get to it again in the future, we'll get the same GUID, right? We won't just come up with new GUIDs each time. We can also use it for avoiding to repeat calls, right? So if we have the send mail, we can then also wrap that into an effect.capture, and that way we won't execute it again. And we're also able to remember the result of these calls, right? So if we have this fraud detected.approve, we won't call it each time we restart. We'll just remember whatever the result was, and then we can go on from there. So let's have a look in code how we can actually change this code from before into something that works. So we could do effected, and we can also do just capture. We'll get to that. So go like this. Transaction ID. Right, so now we have a situation where we're actually using the same transaction ID. We can have a quick look at it. Yeah, so let's have a look. Go like this. Right, so now it's 4700, right? And we can do stop and a restart. And it's the same, right? So it's 4700. And this is basically the first abstraction that we can use to I guess ensure that that despite restarts we're going to get into the same state as we were in before, right? So there's some other concepts here, right? There's something called idempotency, which I guess maybe you know, right? But that's the concept that these endpoints, they will recognize that it's the same transaction ID. So I guess the payment provider, if you provide the same transaction ID that like they've seen before, they won't do the side effects, or they won't do another reservation, right? So I guess depending on this, like how these lines works, it might be okay not to wrap them in effects, but we can do it. It's okay, right? But let's assume that the payment provider is okay. But what we definitely don't want to send out an email order confirm or email the client, the customer, another order confirmation email. So then we can also do capture here, right? Like this. Also, we don't have to have this ID here. We can have the ID if we want to. We don't have to have it. It makes it easier having the ID if you want to look, investigate the state of the flow, because then you can look at these different effects, what the value is. And then if you have a name for them, it's easier. Otherwise, we'll just get a number. But yeah, it's okay. We can also do it here, right? If we assume that the shipped products is not idempotent, right? So we can't actually see that here, but it depends, I guess, on if this endpoint is able to recognize that it's the same order. I guess from what we can see, it won't actually, because it only has the custom ID and the product IDs, right? So you wouldn't actually expect it, right? So we would probably want this to be wrapped in an effect in order to avoid it to be being re-executed. And we can also see that we can then get the result of this actually back here. I guess that makes sense, hopefully. Otherwise, just ask. But that's the first trick, right, that we can use. We can just take these captures, and then that will change the code from being, I guess, non-deterministic or a bit chaotic into actually having the same behavior despite restarts. Cool. I'll continue otherwise. Awesome. So another yeah, so I guess winding back a bit to when I did my PhD, and also some of the things that I noticed as an enterprise developer for different banks and stuff was that that when we have a message-driven system, and we normally use these sagas, I'm not sure if you're familiar, but there's like a pattern, a saga, where we have an event handler per message type, and then we get the different messages, and we have to try and reconstruct the flow in this, I guess, in this representation, which is not that easy because our code actually gets, yeah, it looks very different, and it's a lot harder to actually see the flow in this implementation. So that was why I started thinking about this. Okay, so how can we actually try and keep this this flow, the simple flow that we had before, right, where we just had one line of code and then waiting for the next one? How can we take these other approaches in like, yeah, when we have message-driven system and then having the code look the same? That's where messages comes in. And as I said before, messages are used. Basically, we can use them to say that we want to wait for a message of interest before continuing the code execution to the next line, right? So we have here an example, right? Messages of first of type, funds reserved. So I want to wait for funds reserved before actually continuing to the next line, right? We can also have timeouts here, so we don't just hang the application or the process for an infinite amount of times. We can say I want maximum to wait for 30 seconds, right? And I want the first of funds reserved. I can also do it for multiple messages. Sometimes we have these situations in a message-driven system where, of course, we might get different result backs depending on what actually occurred, right? So we can do that as well, saying I want to funds reserved or funds reservation failed, and also have a timeout. Finally, we can, I'll get back to that a bit, but we can also delay the suspension. So normally in a situation like this, we will suspend if we don't have those messages yet. The framework will suspend the invocation immediately to free resources. But if we expect that these messages will get to the process fairly quickly, then we can actually leave it hanging in process for a while, waiting for these messages. So that's the max wait overload you can use for that. Yeah, you can do also link-like logic, right? So this is the messages abstraction is similar to link, right? It's something called reactive programming, which I guess if you've been implementing or doing front-end programming, maybe you know, but basically, yeah, it's this it's similar to link, but it's just push-based instead. So yeah. But anyways, so we're able to say take onto timeout of type some event will take 3, and then we'll wait for the completion of this chain of reactive operators. So that's quite cool. Yeah, and that's a shorthand. So as we saw before, you don't have to press or do messages dot. You can just, or effect dot. You can just do message like this. So let's have a look. Yeah. So so here we have the same flow again, right? But now it's message driven instead. And yeah, so I don't know if you guys have implemented these Saga patterns. That's different. There's a lot. That's service buses that have them, right? Mass transit, Rebus, and service bus. All of these have them, but they normally also Wolverine. But they normally force you to either to write some like state machine declaratively, or have a handler, a message handler per message type. But this approach, right, actually allows you to write the code in a way that, like we saw before, actually resembles the kind of like flow from top to bottom, right? I hope that makes sense. But yeah, any questions or shoot? I guess not.
One quick question.
Yeah.
The bus, you mentioned different buses. Does this have like its own bus, or do you work with different buses? Yeah, so it doesn't have its own bus. It's actually a completely different problem. These service buses that they try and integrate between different I guess methods brokers. So we'll have a look. Let's see if I can. What's the best way to show it is. So we're actually going to get to that, but I think we can do like this probably, which will be a quick way of showing it. But the short, it's a good question. The short answer is that it's not a mess, or it's not a service bus. It has this kind of like approach where you can implement the flows in this new way, but it needs to integrate with the existing ones. And the way it does that is, so here's a symbol that I have a better example that comes in the presentation, but just for now we can just look at this simple example, right? So this is a flow handler from mass transit, right? You do the iConsumer, and then you can have the different events of interest down here that you actually consume, right? And the way that you integrate these two worlds or different approaches, right, is just that you take the
service bus, and then you send the message to the flow. So that's kind of like the consumption side. I hope that makes sense. I think there's a better example coming up, but basically this is what goes on, right? That you have you just receive the message in the event handler in the service bus, and then you redirect it into the flow that needs to receive that message, and then yeah, so that's how you wire those two worlds up. But yeah, it's a good question. But the whole kind of like implementing a service bus has a lot to do with these declaring queues and kind of like have the same programming model across the different message brokers. Of course, you can also have like here's an example in Kafka, right, where you don't actually use a service bus, but you just have a direct implementation against Kafka. I think also. Let's have a look. All right. But anyways, the point is the same, right? That we'll just consume messages. Let's have a look. All right, this probably wasn't the best example, but yeah. Anyways, the point being here that if you have a direct implementation against RabbitMQ or Kafka, you just again do this kind of like direct send the message to the flow of interest, right? And then that will continue from there. So hopefully it's fairly easy to actually get the message to the right flow. Yeah, but good question. I guess one more
Thomas,
thing.
Yeah. Before you move on, there was a comment in the chat, and I didn't catch whether it got discussed, but somebody raised that if a payment needs to change cards, the transaction ID may have to change depending on the bank. And I don't know whether that was something that got talked about already in the flow of your discussion.
Okay, yeah. Let's get back to it. So I guess just for simplicity, just go here. So yeah, so of course there's a lot of kind of like specific business requirements here, and kind of like the business how it actually works and stuff. It's true that if you have that the order is going to have or change the payment card, right? The customer actually ends up wanting to using a different card, right? Then this will have to change, which is true. And the way, so this is, I guess, not specific to Sleipnir, but in general, right, that would mean that you would have to handle that somehow, right? And I guess the normal way would probably be that you would have some kind of, that the order would actually specify what kind of payment from the customer it would like to use. That could be at least one approach, right? And then you would create another order. You would ensure that this one was rolled back, right? I guess this might have failed, right? And you do the compensating transactions, and then you would create a new one. But that's true. It kind of like, and also, I mean, this example here is kind of like trying to show it from the simple world, at least have some kind of not too contrived example, but the reality, of course, is that these things get more complicated quickly, which also I think is a good reason why we would like to have this. At least this other programming model, I think is quite nice. Maybe we can just have a quick look at this bit more elaborate example. So I think that these when you use sagas and stuff for actually implementing these things, and you also have to have the compensating actions, having this, or just using a more simple term, failure handle. Actually, the code becomes really hard to understand, and I've seen some in the bank I work where they have these kind of like diagrams, finite state machine diagrams of the different states that the system, this saga could be in, and that would be like 50 or something, and you'll have to try and look at that to see if everything was handled. But if we implement it like this, it becomes more aligned again with the kind of like normal code that we see. So the point here is that there's something called, sagas. Sagas has this concept of compensating actions and stuff, that each action has to have a compensating actions associated to it. But if we just, I mean, don't think about that terminology, here we could just say that, okay, basically, if we are halfway through the flow and we experience a failure, we want to clean up, right? We want to we don't just want to, stop the world and have this kind of half-completed flow. We want it to be cleaned up basically. And here's an example of that, right? So depending on how far we got in the flow, we actually want to have some kind of, I guess, canceling out or compensating actions being executed, right? So here we can say if we have the product shipped and that failed, then we want to cancel the funds reservation. If the funds were captured, or if we failed at the funds capture step, we want to cancel the reservation and product shipment. And here's actually also an example of why we don't just always want the Saga to have this kind of like compensating action, because in this case, if we actually had the auto confirmation email sent and we still wanted to cancel, right? We want to reserve the payment. We don't want to cancel the reservation because it doesn't exist anymore. We want to cancel shipment as well. But I hope that makes sense. So hopefully when you actually get to these real world, more messy situations, that this kind of new approach of implementing these things will help you out. At least that's the design goal from my perspective. Cool. Yeah, okay, yeah, so we had already talked about this, but yeah, we have these different service buses and they actually handle this differently. I think this new approach is quite nice when you have to implement these things. Suspension, yeah. So let's just talk a bit about the suspension. It's something that these other frameworks that you might know, I'm not sure if you know, but Azure Doable Functions, and there's a company called Temporal also, which do the same kind of thing. It's not the same exactly like this. It's different architecture and sliding, and also the abstractions are different. But essentially they're very much alike. And one of the things that they don't really talk about is this concept of suspension. It's very implicit in these other frameworks, right? You don't really have you don't have the ability to decide when you want to suspend. But it's of course important that we can suspend, because we don't just want to take process resources. If we do like a sleep for 7 days, like here, we want the kind of like the resources that the flow or the job takes up to not, be taken from the process, especially if you have a system with a lot of things going through, right? That won't actually be a good situation. We'll end up exhausting all the resources on the process. Yeah, so it doesn't initially maybe seem like an important feature, but actually what underpins a lot of the nice things that we get. We can wait for external messages, for instance, like we saw before. It can also be useful if you have a situation where we have exponential backups. So we have a downstream service that's down, and maybe we're using Poly for it. But if the service is down for a long time and we keep on having traffic coming into the system, then actually it's nice if we have the possibility in code, right, to say now I want to suspend, because otherwise it actually might also bring this service down, right? If everything is just waiting and doing exponential backup, waiting for the service to come up again. Finally, we have this thing where if we have one flow calling another one, the parent flow or the caller can also be suspended while the child or the children actually are completing their execution, which is also nice. Yeah, so one thing here is that if we use suspension, we also want to use effects, because then we are ending up with actually having this restart ourselves. And that's, if you know Azure Doable Functions Temporal, they have this kind of like restart loop going on a lot, right? So that's very explicit. But also here, right, as soon as you have a delay and you know you're going to restart in the future, then you have to use the capture of effects in the previous code, like you can see here with the process order. Awesome. So let's look at the frameworks. We already looked a bit on it from kind of like abstraction point of view, but let's look at it from a higher level, what it's about, right? So it's a framework which will help you out with ensuring your code is executed to completion despite crashes and restarts. And like we saw before, it provides some abstractions that allows you to write ordinary C# code, which is resilient, right? So that's quite nice, crash resilient, I guess I should really say, to be clear. All right, so the architecture of Enlightening is, which is also a part where it's different from Temporal and Azure Doable Function, but it's basically just a NuGet package, and it lives together with your service code, right? Your process code. So it's similar in that aspect, like Hangfire, as the same architecture. So it just lives with the code. in a NuGet package, and it has then an integration with the database for actually persisting the state. Yeah, so, and this allows it to scale automatically with the number of replicas. And then it's able to, I mean, keep an eye on crash flow, postpone flows, and interrupted flows. And it will automatically resume these on one of the replicas when it actually sees that these things are not are eligible to actually be executed again. I hope that makes sense. So the way that you actually start a flow, the way that you define a flow, we actually also saw that first, that you implement a class and you just inherit from the flow. You can then specify the input parameters. You can also have one that actually doesn't have any input parameters. But you can have one that has one but doesn't return anything, and you can have one which has one and returns a value. So that's these two cases. The way you actually interact with the flow is that there's a source generated flow, or like I guess proxy that you call through to actually invoke or communicate with the different flows. So here we had it was called order flow, and here it's actually called order flows with an S at the end, and you can inject that normally as you can in IRC in the net, and you can then say I want to run the flow, and that's many different possibilities, right? I guess one thing I can just quickly show is if we go over here, as he has this attribute generate flows, so that's what actually will allow it to do this. And we can also see if we go to the controller is there, right? So we also have this code here, right? Like we saw before, and we can inject it. So it tries to at least allow you to do this in a simple way to actually start to use. You don't call the flow directly, you always call it through these proxy type. Then as we also saw, we had this message-driven part of Sleipnir, right? Where you actually get messages from the outside, and you then can direct them to the flow, to the right flow, and you can send. So you can send messages. You also have this bulk support where you can send a lot of messages at this immediately into the framework. So for instance, I think Kafka has this concept that you get a batch of messages, and so you don't have to send each one like in parallel or as a single message in parallel. You can actually or do like a loop where you wait for each message to be processed. You can just send them all in bulk, which is quite nice, at least when you get to larger scale. And here actually this was also leading back to the question before about the message broker integration, and I guess maybe just have a look at this now that we actually had a question about it. But yeah, here's the different one, right? So you have order handler, message-driven flows. This is also a mass transit consumer, right? So we have all these different messages, and what we basically do is just that we pass it to the right flow by saying, so this is actually saying, so it's a flow with this order ID, and we want this message to be sent to the flow. So it's simple to do this kind of like integration between the service bus world or the message broker world and actually getting it to the right. So let's get back to it. So I think a good way to understand these concepts is actually looking at some different examples, right? And the first one that I think is quite nice is invoice generation, right? So, and that actually shows that we can code in a different way despite being a long delay. So if we have a flow, or we have some job that we need to do where we at each month needs to generate an invoice and email it to a customer, and then we want to terminate the flow when the customer's relationship actually terminates. Then how could that look, and how could that be implemented? And we can have a look at it here. So we have this flow, right? Initially we want to find out what the first of the month is, and then we want to add 1 month, and then we want to Actually, that was let's have a look. Sorry, yeah, that's right. Sorry. Then we'll wait for see if the customer relationship actually terminated, but we want to time that out actually the next invoice date. If we then get to this, or when we get to this point, if we have a customer terminated relationship, we just want to return. I don't know. We might want to send an invoice just for the remaining amount, but that's kind of like a business technicality which is outscoped here. Then we're going to send the invoice, and then we're going to add a month to the invoice date, and then we can keep on going like this. So this is not normally something that you can do in these other approaches, right? You would then have just kind of like, you wouldn't have the continuity, right, in the code like you have here, where you just have a simple code just running through. You would have kind of like for each month, you would just have the kind of like send out the invoice. So this shows, or this other way of doing things shows actually that you can write code even though there's a long sleep here for months. You can still write the code in the kind of like normal simple approach, which is quite nice. Yeah. So there's a bonus question here for you guys that you can think about, and we can get back to it if there's time at the end. But yeah, and that's also something that schedulable function has, and temporal as well. The thing that the space consumption actually is a function over time, which is not something that we are normally used to, right? And when we write code, our code normally, unless it has a memory leak, right, it won't actually take more and more space over time, right? But yeah, we'll get back to that, and we can have a look at how we actually solve that. Then there's a batch processing example, which is that we have the same situation as before, where we have an order that we need to be processed, but here we actually have a lot of them, so we get them in one batch, and then we need to process them all. And we can have a look. So yeah, so we have a list of orders like before, and the kind of like the simple approach, right, is that we can just process the order one after the other, and then we can find all the track and trace numbers, and at the end we can publish an event about track and trace numbers. Let's say that was a business requirement, so that can be done like that. We also have the possibility that we can do the different orders in parallel, just in process, where we can use this approach. So the framework allows this, that we can do threading, which is quite nice. And finally, we can also use the big hammer, you could say, where we actually are going to, where we're actually going to ask the cluster to divide the different orders, right, to process them across all the different replicas. So we can use that here with order flows, bulk schedule, and then we can wait for completion, and we get all the track and trace numbers. So that's kind of like 3 approaches, and I guess depending on kind of like the number of different, the number of the batch size, I guess, determines which approach we want to use. But it's quite nice that we have all these possibilities in the framework, I think. Yeah. So again, I'm a bit unsure about all of you guys' background, but an important concept also here, which actually I guess is related, maybe a bit indirectly, but to this kind of space is the outbox pattern. Does anybody know the outbox pattern, or are we okay to talk again?
Yeah, I'm familiar with the outbox pattern.
Nice. Cool, yeah. So it's a pattern that we use to solve the problem that we want 2 things to happen, right? We want some kind of state change to happen locally on our microservice, but we also want an event to be published. And the thing that we're trying to solve is that what happens if we can save to the database, but we can't publish the event, or vice versa, right? That we publish the event, but we can't actually save to the database. And the way we solve this is that we implement this outbox, which is basically like a background service which looks at a database for messages that needs to go out, and then it will publish these events to the message broker. So it's actually, I would say, a fairly heavy abstraction that we implement when we have these replicated services, right? We want the outbox actually to, or we have different, the outbox might be running, at the same time in parallel on different processes trying to take messages out, and we don't want all the messages to be sent several times and stuff. So, so it's a bit heavyweight, but it's even been implemented a few times. So yeah, I mean, it's definitely doable. But one of the interesting things about the outbox pattern in this case is that when you use it in Enlightening, these doable execution frameworks, you actually don't need it anymore. The kind of like the requirement goes away, because actually the framework ensures that both of these lines will be invoked, right? And we can also do the capture if we wanted to, right? So we can do capture. We can do await, right? So we can remove this, right? And we can do the same, right? So in this case, actually, if one of the if the bus is not available, and after we've done the process and persist order, then we can have poly or something else, right? Doing a back off, or we can sleep for a bit, or yeah, suspend the invocation and then come back again. But we won't execute the previous step, right? But eventually, when the message bus comes up again, then we can actually publish the event. So I think that's quite nice, kind of like thing that you get in this programming model for free, is that you don't need outbox. So that's quite cool. Yeah, so we don't need it anymore. The newsletter sender. It's another example. Let's have a look. Newsletter flow. Yeah, so let's just say that we have a lot of the mails that we need to send out, and we have this loop, and we're just going through creating emails and sending them. So the kind of like the simple approach here would be to go like this, right? Let's have a look. Right, so if we're going to, I mean, if there's a lot of emails and we want to kind of like not resend them if we are being restarted, then we can use this, right, to actually ensure that we won't send the duplicate emails to customers, right? And again, like we saw before, this actually also has the problem-ish, you could say, depending on the number of recipients, that actually the space that we're going to use in the database, and the actually time it takes us to restart is a function on the number of recipients, right? So if we have a lot of recipients, we're going to use a lot of space, and it's also going to take more time actually to do the resume, because we have to run through the loop and then do kind of like ignore all the captures that we already did. But this is, I think, is a way, it's a place where Enlightening actually provides a different approach, and I can just show it quickly. So we can actually, with effects, we can also do create or get. We can go index, and we can go 0, right? So we can go like this, and we can go effect absurd index value I plus plus, right? So by using this different approach, we actually we're not. I mean, we're actually changing the offset in the loop instead of always having the offset being the beginning of time and then just jumping over the stuff we already did. We're actually changing the the offset, and this, of course, doesn't take up a lot of space, right? And it's also quicker to do the resume after. So this is the one where actually Enlightening has a different approach. So it allows you to take a different approach from temporal and executable functions, which I think is quite nice.
Would the I increment I twice, because you have it in the upsert? And
oh yeah, sorry, yeah, okay, yeah, you're right. Sorry, yeah, that was my mistake. Sorry, yeah, good catch, yeah.
So this, it needs to be this instead, right? But that's yeah, good. Actually, yeah. But you're right, yeah. Sorry, yeah. So I guess that's one of the hardest thing in software development, right? Is I think it was in computer science we heard it once. So this all fly one problems, but yeah, that was an example of that. But yeah, good catch. Definitely, you're right. Yeah, we can also have a look at an example that actually has an advanced message filtering, which is this loan application example, right? So if we have a flow which needs to approve a loan, and the way it works is it sends out a request, and then there's the different fraud detectors. Let's just say 3 that will look at the loan approval, and then they will make or return with their decisions. We want to, at least we have a timeout, right, where we want the customer to have a reply. So we can't just wait if some of these fraud detectors are not working. We can't just wait or let the customer wait. We're going to have to make a decision. But we're also okay if it's just 2 out of 3 that actually replies, and then we want to use their decision. So one of the things that gets a bit difficult in this situation in a normal system is that you might have this kind of like that messages gets back after the 15 minutes, which might change the way that this loan application decision is made, right? So let's say that we want, like, if just one of the fraud detectors is going to say no, I'm going to reject the application, then we're going to reject it. But if we get 2 out of 3 that says yes within 15 minutes, and we didn't get the last one, then it doesn't matter if that eventually is going to come through, because we already decided on what we're going to say to the customer. Yeah. So let's have a look. Yeah. Loan application. There we go. Yeah. So let's just go straight to the solution, right? So we're going to send a perform credit check command on service bus, and then we're going to wait, right? So here we actually have the logic. We're going to wait for 15 minutes. We're going to only be interested in credit check outcomes. We're going to take 3, and we're going to wait for the completion. So this value here will resolve, you could say, if there are 3 messages, or when the timeout has completed or actually fires, right? And then we might end up in a situation where, so the logic was if there's less than 2, we're always going to reject. We can't just have one fraud detector decide. Otherwise, we're going to look at if they're all approved, or some of them if they're all approved, then we're going to approve it. Otherwise, we're going to reject it. So hopefully that makes sense. But that's kind of like a more advanced way you can actually look at this kind of like link quality of the messages, which is also quite nice, I think. Yeah, we have now I have the bank transfers. I think the last example, and then we can maybe just have a chat about what to do next. But so the bank transfer example is kind of like a classic example of a situation where you need a bit more synchronization that you get normally. But so each flow, and also I guess job, and also message handling normally in distributed these enterprise architectures, they're always kind of like the message is only handled by one handler at the time, right? The job in Hangfire is only handled by one instance at a time. It's not being handled in parallel at the same job, and the same goes for Sleipnir. The single flow is only invoked once at a single in a single process, right? But there is a problem when we have this kind of like that we need to synchronize between different flows. So a bank transfer is an example of that, and the way it works is that that if we have a situation like this where we can actually get available funds, right? Before we can actually make the transaction. So let's say that's kind of like the API that we're working with. Then we might end up in a situation, right, where we say, okay, is there enough available funds? We can't make the transfer we're not allowed to, let's say, have a negative amount on the sender account.
But the problem here becomes, so it's also normal like threaded programming, right? That we might have this check, say, okay, it's fine. We have 2 transfers running at the same time. They're both going to say, okay, there's actually enough funds. And then they're just going to make the transactions. But the problem is that if both of these are allowed to check for available funds, they might actually end up deducting the sending account, I mean, more than it's allowed to. And that's why you kind of like need these logs or distributed logs, which you can use for actually synchronizing between different flows. And that's basically it. In Enlightening, you can do like this. So yeah, you take the log and you then dispose it at the end, and then you're sure that it's only you who actually allowed to this critical section here. It's only you that's going to be allowed to actually execute code here. So I think one of the problems when actually implementing these distributed logs is you have 2 problems, right? The first one is that if you just have a distributed log that's time-based, right, you might end up, I mean, crashing here, which is what you don't want, and then the log expires, and then somebody's going to take over. Then you might have kind of like a half-completed transaction, right? But actually, the way the Enlightening works is that it's not time-based. This log here is actually for the flow itself. And but the flow is restarted, right, by the framework. So when it gets to this point again, it's actually allowed again because it already has the log, so it's allowed just to pass through here and complete the flow. So hopefully that makes sense. But it makes this kind of like when you have synchronization across different flows, it makes that easy, and it's also quite like a strong feature, I think, that you have. So yeah, testing. So have we've gone over an hour now, an hour and 10 minutes. So I think maybe it's a good time to maybe have a talk about if there are any questions, or if kind of like what you want to see next, or if you're too tired. So there's a bit about testing, how you would actually test this flow, and then there's also a bit more, I guess, not theoretical, but kind of like what are the challenges that you actually face when you have to build a framework like this, if you want to hear more about that. I don't know. Does anybody want to pitch in?
I think that would be great. We can go as long as you're conscious. So let's do it.
Okay. It's only 3 o'clock here in Denmark, but yeah, okay, cool. That's awesome. So let's just quickly have a look at testing. So testing is yeah. So I haven't worked that much with executable functions and pros. I'm a bit unsure how you actually test them, but at least the approach in Enlightening is that it tries to make these integration tests as easy as possible. So there's an in-memory storage provider. Of course, you can integrate against Postgres, SQL Server, and also MariaDB. But there's also an in-memory storage provider which you can use, for instance, when you just run locally, or you can use it in test environments, and then you can register your IC bindings. We can have a look at it here. So this is an example of a test. It actually it tests the order flow like we saw before. So what it wants to ensure is that the code actually uses the transaction ID provided in the effect like we saw before, right? So it tries to ensure that if you restart, you're not going to just invent a new transaction ID and use that instead. And the way that this test actually accomplishes this is that it creates a transaction ID which it say, okay, this is the transaction ID you're going to use, and it captures actually the transaction ID that was used by actually creating a stub of the payment provider client. So we can see here there's actually a reservation here, and it captures that and stores that as a variable. So so it registers the order flow as a singleton, so the framework will always use the same order flow here. Then it creates a container, and which is kind of like what the framework does behind. We didn't see that in the integration, but it actually, you can just do this by hand. So you create a flow container and you create the flow with the container. Then you can create the test order and you can run the flow. And one of the things here is that you can actually set the initial state of the flow, which is also good for versioning. So versioning is a large topic in itself, but it's also useful there as well as here. And when you actually do tests, right? So we can say, I actually want the transaction ID to have this value. Then we're going to run it. And then when we finish, we're going to assert that these two are actually the same. So this thing is quite nice. And you can also debug this if you wanted to, right? It's just, yeah, running in memory. So no issues there. Yeah. So I guess some of the challenges of durable execution. So I think this, at least, is also quite nice to hear you guys input. This is one of the, I'm going to do a presentation in Copenhagen in May, and I think I would like to have this emphasized more if possible, because yeah, it's kind of like I've already presented a slide near to them, so I need to talk about something else. But yeah, let's start out maybe with minimizing read IO. So the framework, at least when you're creating a new flow, right, then there's nothing to read, right? So it can basically just write a line, one line in the database, or one row, sorry, in the database, saying now there's a flow existing, and then that's it. It doesn't have to do anything else. But when it actually needs to restart and resume an existing flow, this is a different story, right? Kind of like the naive approach would be, which is, I guess, a symbol for understanding, but not very efficient. Let's have a look if we can go back to the ordering. All of flow. Yeah. Yeah, we can just do like this now. Get back to that. Right. So the naive approach, right, would be that we would just say each time that we reach a captcha, we're going to check for the database to see if that captcha has a value, and then we use that, right? So that would mean here that we would do 4 IOs, right? Which wouldn't be very efficient, right? So the alternative for the solution is that we'll read everything up front, right? So that's kind of like the trick. If we're restarting a flow, then we're going to read all the messages and all the effects in one go. And then we have them ready for the framework when we actually execute the code. And that's a lot about actually this building a durable execution framework is actually trying to minimize the number of IOs, because that's a lot of where the performance is being used, right? And that's where we can get a lot of performance. So serialization. So that's actually also a lot of serialization. It's the same for temporal and also as a durable function. There's a lot of serialization going on. Because all these captures and all the messages, they're all being serialized, right? So actually having an efficient way of serializing data is important. By default, Enlightening uses JSON, which is, I mean, is very well supported in the .NET framework, and it's also, I guess, good enough for most cases. But you could ask, what's the cheapest serialization? At least I've seen in other places I've worked that there's a lot. So it wasn't Sleipnir. They built their own event sorting framework and Saga framework, and a lot of what they were using all the CPUs on was this serialization and deserialization. It took up a lot of resources in the processes on the replicas. They were also using JSON, but of course you could say, okay, what's the cheapest serialization? Well, yeah, you could use something like message pack, and actually Sleipnir supports that you can, use your own custom serialization, which is quite nice. But I think I also hinted on this before, right? That we actually had the cheapest serialization, of course, so it's a trick question, right? It's no serialization. And the way we can accomplish that is this trick that I also showed earlier, right? That we can say, I don't want to suspend yet. I want to keep hanging, have the process keep hanging and waiting for this funds reserve message, right? So here's, for instance, we already have the entire object graph created in C# in the memory, right? and we can just keep that until we get that one message back, and then we can continue from there. I think that's also a nice performance trick that you can use. Of course, as I said before, and that's also why it's a decision that's up to the developer, right? Is that it's okay to wait, let's say 10 seconds. Maybe it's okay to wait longer for a system where there's not a lot of traffic going through. But if you have an order system where there's a lot of orders going through all the time, you probably don't want all the orders just to stay in memory, right? Because then you'll end up dosing your own service, which is not good. So we had the state explosion issue also, which is also something that these Azure durable functions and temporal suffer from. Is this situation where you have that the amount of space and also the execution restart time actually increases with the number of these effects that you use. And we saw one approach for actually improving this was that we could use the index, save that instead of doing a capture inside the loop each time. But there's another approach that we can use, which is also not something that temporal and Azure durable function uses. But I would like to hear you guys what you think about this question. But let's say that we have an effect inside an effect. And so we have a loop here like before. So we have wait, capture, and then we have an outer loop. So let's say that we've completed the loop, and we also completed this effect here, right? So when we complete the loop, this effect also is completed, and when we continue. The question then is, if we have that this is completed, do we actually need all the captures inside here? And the answer is no. We don't need it, because we already have the result here. So when the framework is actually going to get to this line again, it's going to recognize that this capture was already completed, so I'm just going to jump over it. And that actually leaves us with the opportunity for the framework to clear up these effects inside here. So if you ever use temporal or Azure durable function, has this concept of continue as new, which is their approach for actually trying to solve this problem with the state explosion. But if you use effects inside effects, the framework can actually handle this for you and keep the state down, which I think is a nice feature. But yeah, maybe it's a bit much to get your head around effects inside effects. But the concept is fairly simple, right? If this is already completed, then it won't actually execute this code, and that also means that these effects are no longer needed, unless of course you want them for actually finding out what happened in the. You might want to keep them around for deducing what actually happened with the flow originally.
I have a question.
Yeah, sure.
Could you do a similar approach with a linear flow to just keep track of the last one? And then as you're resuming, notice that you've gotten this far and just skip over all the previous steps?
Yeah. Yeah, definitely. You can, yeah. So I haven't implemented it yet, but there are some. I'm thinking about creating some similar to you have in Link, some kind of like looping helpers or functional operators. For instance, in Link, you have an operator called an aggregate function, which has a seed, and then it kind of like rolls. So I guess in functional programming, it's a lift fold, I think it's called. But you could have the same concept here, right, where it would do like a fold, and it would only remember kind of like the current value, and then it wouldn't need to you could just go straight to that, say, okay, what's the current value, and then feed that to the aggregate function, and then it could then get a new one. It could save that, and then it could go like that. And it could also just have kind of like we saw before, the offset into the recipients. So you wouldn't have to handheld it. Sorry? Yeah. Let me hear.
It also feels like you might have a durability concern. You know, how long do I save that I finished? It feels like that might need to be a user configurable value, because, for example, if I come back in here and try to send the email in a week, I still want to note that it's done. But do I really want to keep a week's worth of emails or a month or a year's worth of emails?
Yeah.
Just on the off chance that somebody happens to resume a transaction? That feels like now I've got a huge database just maintaining, yep, I'm done.
Yeah. True. Yeah. Good point. Yeah. And actually it is a value you can set. So here we're just looking at some of the options. There's something called retention period. Let's have a look. Retention period, there it is. So it's actually, the retention period is not for effects like we saw here, but it's for the whole flow. So it means that after the flow has completed, how long do you want to keep it for? So that, I guess, addresses at least part of what I'm hearing you say. So you can say that I want that to be a week or 2 days or something, and that will also kind of like ensure that you like deduplication, right? So if you have the command going through several times, it won't actually execute the sending of the email several times because you have the retention period deduplicating that. But yeah, you don't want it to just stay around because then it will take up a lot of space, slow down your database, and I mean, not be optimal. You could do the same. I mean, it's definitely implementable for inner effects like this as well. So you could say if the outer flow, the send email is really long running, I still want these to be kept around for a while, but not for too long. So I hope that answered your question. Yeah, but it's on the flow level, it's implemented. It's called a retention period, and it's definitely it's developer, or you set it, the user actually sets this, right, or the developer using the framework sets this, because it's difficult just for the framework to know how long you actually want this to be implemented for.
So yeah, that retention period is perfect. That's exactly what I was looking for.
Okay, nice. Yeah, cool. All right, so minimize write IO. So we looked at the read IO. And I guess you get this from actually thinking about these things for way too long. But the question is, do we also have to store the results of effects immediately, or can we get away with something else? So if we look at the order flow like before, right, we could have a change of requirements, right, that we want to send a follow-up email after a day. So we'll do a delay for 1 day, and then we'll send a follow-up email. That actually means that when we then resume, we don't want all these things to be executed again, right? So we'll do like this, right? A similar approach, just that we capture everything, right? So that means that when we then, after a day, get back into the code, we'll just jump over all the steps. But that also means here that when we're actually executing this, right, we do 1, 2, 3, 4, 5 IOs, right? And the question is, can we do better? And that actually, again, is not something that the framework can do just by itself. So the framework is not allowed just to say, oh, I'm just going to, put all these together, all these different captures together and just save them in one bunch, because there's already executed a lot of code at that point, right? And if it then fails to actually save these captures at the end and just one go, if it crashes us, restart it, right, it will just re-execute these things, and we lose the kind of like the guarantee that we get from capture. But you can think about it from a different perspective as well. So we can't always do it, but sometimes we might actually be okay with it. So for instance, here we could say that the payment provider client has a transaction ID is actually idempotent. So we're okay if this step, if we bulk, let's say we bulk this step together with these other steps, we bulk them together. We're okay if that crashes and restarts, because we know all of these, let's just say, for the argument's sake, that all these steps are idempotent, right? Then we're okay with these steps, or with minimizing the IOs from 4 just to 1, using this approach, right, where we can say I actually want to delay the flush of this capture. But the capture up here, the transaction ID is different, right? We want that to be captured immediately. After this point on this line here, we want this transaction ID to stay the same. But that's the idea, is that we can play around with this idempotency. Say that, okay, we're actually okay with some of these steps. We know they're idempotent, so if it's going to crash and restart again, it's actually okay. But at the end, we want these things to not always happen. So we get kind of like we can tweak this and we can get into we can trade some performance, but still keep this or get some performance but still have this this nice feature that when we then restart after the delay, then we're going to jump over these steps. And I mean, also in general, it's not normally, I think, a case where you have idempotency, for instance, for a third-party payment provider, that is kind of like you can go for days or months with something being idempotent. They will probably also delete some of these idempotency keys after a while just to see resources on their side. Yeah, so the framework uses this internally, for instance, for timeouts. So timeouts also has this kind of concept that you can register a timeout, and it's not necessary that we have to I mean, write that to the database immediately. We are okay with that just being I mean, buffered together with some other effects, or the write of the flow at the end before we suspend it and stuff. So yeah, the framework uses that. So that was actually the last slide I have this. So there's one called least-based synchronization issue, which is kind of like the most theoretical one. I haven't gotten to that yet, but basically there's when you have least-based implementations of synchronization, I think it's something I saw in Azure Blob Stories also has this thing that where you have a lease and you get it for, let's say, 15 minutes or 5 minutes, and then you have to renew the lease. And then you can then extend it for another 5 minutes or half an hour or whatever. But that is actually something from or time is kind of like a difficult thing to grasp in distributed systems, because you actually have clock drifts, right? And you have the clock might actually be set. I mean, by the system to go back in time and forward in time in kind of like a chaotic way. And you also have the case where actually this thing that wants to renew the lease might actually be overloaded, so it won't be able to do it and stuff. So there's a lot of issues, and there is I'm looking into actually. I think Sleipnir will continue having this kind of like lease-based functionality, because that's useful for avoiding everybody to actually step on each other's toe trying to execute a flow. But you can also implement the other part, which is where you use version timestamps. I guess you know that from databases as well, to actually ensure that if the flow is accidentally executed on the same at the same time, you won't end up in a bad situation. But yeah, that's kind of like, I guess, it shows kind of like the most abstract, difficult problem that you can have in this field, I think. But yeah, at least that's part of what I like about the framework, is that you can get to think about things like this. So, that's a good discussion from a guy called, you might know him, Martin Kleppmann or something. He's written this data intensive something book. Yeah, he has he notices in Redis, there was a Redis framework for actually doing these locks, and he noticed that was broken, and so he wrote a blog post about it. So if you want to know more about that issue, you can maybe look him up and and see what it's about. But yeah, that was all the slides at least. So now you've gotten everything I had, and also some good questions. I guess at the end, are there any questions? Somebody who has any feedback would also be nice if you have anything, or shoot.
So I just posted the title of the book. I think you were looking for designing data-intensive applications.
Yeah, definitely. Yeah,
is a great book. So
yeah.
Cool.